Hello, welcome to Feed the Snake, Growing Your Python. This is a presentation that I gave at the WAGISA GIS Conference 2025, and because I never bothered to time it, it is not really a 20-minute presentation with 5 minutes for questions. It is more like a 40-minute presentation, especially if I go off script and ramble. So, in lieu of appropriately editing my presentation for time, this is my redemption moment that I am recording this presentation in its absolute fullness. So if you want it to be 20 minutes with 5 minutes for questions, then you can watch it at 2x mode, which might be cool or not. I don't know. Depends on how slowly I talk. Okay. This is the section where people tell you things about them that establishes their professional credentials and why you should listen to them. I think that's boring. Instead, I'll share some personal things about me. If you notice that I talk kind of funny, I'm from Texas, and no, people in Texas don't talk like me either. My family and I moved to Washington last September. I love watching cartoons, horror movies, underwater and space horror particularly, but they're all great. I'm currently listening to a Deep Space Nine rewatch podcast. I bought some fruit trees and am battling the deer from ruining them. Really enjoying that spring lasts for months. Here, I have owned and wrecked several motorcycles and a scooter. Anyway, moving on, let's talk about Python. That's right, it's a Nokia themed presentation. Also, I don't read slides, not really my thing. Not that I oversold it, but we do have a lot to cover. As I put in the abstract, this presentation is the presentation that I wished I would have had when starting my geospatial Python journey, which is to say, when you're starting out with the programming thing, there's a lot of questions that aren't answered generally. Lots of necessity, mother, invention stuff. But outside of stringing things together, there's just a huge gap in how do I get better at this, or what does better even look like? So, 11 years into GIS and programming, I finally have some answers, or at least strong opinions loosely held. There's going to be lots of stories. Back in Texas, I was at a restaurant after a conference and sitting with a bunch of GIS managers at a family-style chicken and catfish place. Not that you need to know that. The salads are sugared. Not that you need to know that. Anyway, the county GIS manager says something along the lines of, I would really like to meet someone who can write a script from scratch. I don't know anyone that isn't just copy pasting things from somewhere else. And I wanted to be really offended. Like, me, I can write a script from scratch, and sometimes I can. But the more I think about that interaction, the more that I understand that writing code is a process. And it's the kind of process that requires a lot of reference work if it's not something that you do every single day. And for a long time, that was the measuring stick that I had for what is a competent programmer. And now my understanding has changed. This presentation is a rough attempt at trying to articulate that understanding. We'll start here because it's kind of the most important thing. The reason being, you'll find it very difficult to adopt modern development practices when you're stuck writing all of your code inside of ArcGIS Pro. And this entire presentation is about adopting modern development practices. The very first step is transitioning into writing your code inside of an integrated development environment or an IDE. Everyone has opinions on what you should use. I will say that most GIS shops here in North America are Esri shops and Microsoft shops. That said, the lowest bar to entry would likely be Visual Studio Code, also known as VS Code. It's free, has a ton of extensions. Technically, it is a code editor and not an IDE, but for GIS development work, it is more than enough unless you're writing ArcGIS Pro add-ins. And just a side note on things like PyCharm Professional or other paid IDEs, I wouldn't spend money on that. It ends up being the same cost as a Copilot subscription, which is a better value. And maybe we can talk about AI at the end. I have thoughts. ArcGIS Pro uses Conda, specifically Mini Conda, to handle all of its Python functions. Conda is a package manager. For our purposes, it is a fancy tool that handles how disparate libraries can coexist within a Python installation. However, it is language agnostic and can be used to do non-Python things as well. And while you can certainly connect to the Python kernel that ArcGIS Pro utilizes, I would not recommend this approach. From years of doing stupid things and breaking Esri installations, my official advice is to not touch any of the Esri default installations. Just don't do it. Upside down Nike swoosh. What this means is that you'll need to install a separate Conda installation on your machine. You have a few options as detailed in this slide. Mini Conda and Mini Forge are both free to use, and Mini Forge is open source. There are some licensing issues to be aware of if you want to use the full Anaconda distribution. Let's quickly see how to set this up. Through the magic of video editing, we can make this entire process fit into a GIF. End to end, this took about 9 minutes. Fortunately, we only need to perform this process at every minor release, like 3.4, 3.5, or whenever you want to spin up a new environment. After this quick operation, you now have access to ArcPy in an environment that is separate from ArcGIS Pro. This is a fairly painless process. And by fairly painless, I mean I'm learning new things all the time. So you might have noticed that the code on the slide is different from the code in the GIF. And that's because the code in the GIF is using some syntax that's like Esri : ArcPy. And what the : does is tells Conda, hey, just grab this one single library from the Esri channel and then source everything else using the defaults, right? So if you have Mini Forge and you haven't touched it at all, it's a plain, clean installation, the default is going to be Conda Forge. So it's going to try and grab all the other packages that come with ArcPy from Conda Forge, which may or may not work. And in this instance, it did not work, and it took me like 90 minutes to hunt down the culprit and all this other stuff, and it was a real pain. Use Conda install C, and what that does is say, hey, install this package from the Esri channel and use Esri channel as the default for installing the packages that go along with it. So that's that, just something to know. After you've created this ArcPy environment, VS Code should pick it up as an appropriate Python source. You can see that I like to keep environments around in my daily work. For me, this process was a huge step forward for my growth as a Python developer. Once I got myself working more fully in an IDE, the easier it was to start applying other tooling that improves quality of life. As a side note, I would be remiss if I didn't mention that there is a new package management system called UV, developed by Astral Labs and written in Rust. It is super fast and has been picked up very quickly in other areas of Python development. I'd be willing to wager that Esri adopts UV in the long term. But since they aren't using it at the moment, you still need to grab ArcPy from Conda. and then you could use UV on top of it for additional packages if needed. Generally, the same caution would apply. Don't mix pip and Conda. Don't mix UV and Conda because there can be unintended side effects. It is not recommended. Anyway, quality of life development stuff. That's what our next section is about. Why do you like moving code around? That was a question that a friend of mine, Julian, asked me one afternoon. He was trying to explain to me the benefits of using an auto formatter for my code, but instead of explaining the benefits, he just savaged me with this one question. And it was the right question to ask. I moved code around a lot, more than I care to admit. And yeah, it satisfied an urge for tidiness that I had. But that wasn't the point of programming. Programming is the point of programming. This one question fundamentally changed how I approached programming. I now think to myself, what can I abstract away? What don't I have to deal with so that I can focus on the code? Formatters were originally written and designed to run as command line interface tools against a file or directory. Nowadays, these can be downloaded as extensions within your IDE or integrated into your Git pipelines. We can talk about that later. Black and rough are the only two worth talking about. They are opinionated, meaning they enforce a particular kind of look and feel with limited options to customize it. That's a good thing. We can stop moving code around and instead focus on writing code. Black will make all of your files look and read consistent in the same way that reading a typed letter is easier than something that is handwritten. We move towards a standardized way of writing the language so we can focus on the details of the language itself and avoid getting in style fights with others. So rough is a drop-in replacement for black. It is written in Rust and very fast. Most projects that GIS Python developers are working on are not going to require that kind of speed. But the whole Rust everything is kind of the future of Python tooling. Rough is written by the same developer, Astral Labs, that wrote UV. Black is included in the ArcPy Conda distribution, but it can also be sourced as an extension in your IDE, right? In VS Code, Microsoft has a black extension. They're basically equivalent. Since this is just me giving wild opinions, my opinion is that you should use rough. You'll see that rough is on here twice. It is a linter and formatter. It excels at both. PyLint and Flake8 just flag it for you to fix. Rough can automatically fix it. Just use rough. And I guess it might help to explain linters. Linters highlight stylistic and semantic problems in your code, like syntax errors, PEP8 guidelines, bad coding practices like unused variables, undefined variables, code smells like duplicated code, overly long or complex functions, long function parameter lists, dead code, switch statements, that kind of stuff. And I should have named this section formatting linters and type checkers. Pylance is the type checker that comes with VS Code. It's great. Use it. It's built on the library Pyrite. What's really great is that Astral Labs is coming out with a new library, TY, that aims to be a faster, better replacement. Still in alpha, not yet ready for production use. It is June 2025. It will eventually not be an alpha, and then you should use it. More stories. I'm full of stories today. Who remembers the first time they wrote a function to email them after a script ran? Who hadn't thought to do that? Pepperidge Farm remembers. I remembers. It was 2017, and it was cool. Until it wasn't. And what I mean by that is I had a bunch of critical processes, and I had set up all my automations to email me every single time they ran success or failure. So before I learned the value of work-life balance, I would obsessively check my email at the appointed time to review the results of my automation. And it was super high stress, especially when I didn't receive an email at all. And after a while, I would get absolutely triggered by the Outlook email chime. It was a lot. But what was worse is I didn't have anything other than the email to go by. So if there were additional things that I needed to have known, too bad. This added to my stress, and there were so many times of trying to hunt down intermittent edge cases with essentially nothing to go on. And what did I do about it? Nothing. I just lived like that. And honestly, I didn't know that that wasn't any kind of way to live. So logging, not trees, other logs. I think it took me so long to get into logging because the barrier to entry was kind of high. There is a logging module in the standard library. The syntax is a bit long and messy. This is actually my production environment that I was proud of. And by was, I mean I did some casual research for this presentation and saw that all of this can be easily replaced by the next library that I'll talk about. It's worth talking about what's going on here, though. The first screenshot is a custom module that I wrote. It has a small function here where I write out a basic logger. It takes a parameter of a file path and then uses the stem or file name to make a .log file where it writes out. So every script I have has a companion .log file. The second screenshot are 2 lines that I have in all my scripts. It calls the current file path and then sticks it into the logger configuration to create the log. Finally, I use a library called log decorator, which implements decorators that can be used on any of your functions to have specific logging behavior for each one. The result is a set and forget logging mechanism that I can refer to when I receive an email. This isn't bad per se, but we can abstract it away. Log Guru does all of that out of the box. So use Log Guru. And this goes back to that idea. Do I want to spend my time logging and maintaining my loggers? No. Do I want to submit pull requests to Log Decorator so that Pylance will correctly preview my module functions that use decorators? No. Did I? Yes. And I think we're all making band-aid solutions until someone comes along and does a solution that gets it right. And instead of stubbornly holding on to your solution because it's yours, I would encourage you to adopt the thing written by someone that took the time to do it right. Code. We're talking about version controlling your code, not like geodatabase versioning. And I'm always kind of surprised when I talk about this because not everyone gets it intuitively. I mean, the same people that tell you to use versioning in your geodatabase are some of the same people asking, why do I need to version control my code? So maybe this might sound familiar to some of you. You make a script that you're really proud of, happy with, and then you notice something that needs fixing. Or maybe you just want to try something new. You make a few changes, then a few more, then it just doesn't work, and you don't know why, and you're really deep in it now, and you're frantically trying to remember how it was, then looking around all your files and your emails and your USBs, and there's a vain hope that maybe somehow, somewhere, there's a copy of your code floating around that still works. I've had this situation happen to me several times, maybe more than several times, and it's usually with Jupyter notebooks. Version control will fix that. It won't fix your Jupyter notebook because it makes horrible diffs. Don't do that. use actual .py files. You'll thank me. Anyway, it doesn't really matter what you use on the back end. They are all utilizing the same open source Git technology. I will say that GitHub is the most well-resourced of the big three, which can be good as they normally roll out features faster and better than the other providers. From a security standpoint, they're also a more desirable target, but that generally shouldn't matter for the casual GIS developer. No one cares about the things that you're building. Uh, except you and me. I care about it. I did a whole presentation on Git, and in it, I talked about what makes Git work, and I prefaced it there with, it doesn't really matter how it works. What matters is that it is relatively fast, especially compared to other options, and it has a 97% market share. It's not a stretch to say literally everyone uses it. The beauty of it is that it allows you to walk backwards in time along your saves, called commits, so that you can roll back changes if necessary. Or you can spin up a branch to prototype something and then feel free to delete the whole branch without messing up your main version in production. Hopefully you're sold about using it. Then the next question is, how should you use it? Obviously not a snake reference. I will say there is no best way to use Git, or rather, the best way of using Git is using Git at all. Don't let anyone gatekeep you about only using it from the command line or some other garbage like that. I say this after trying to teach a different presentation from the other Git presentation I just talked about that was all about using Git from the command line. I've come to realize you don't gain anything from using it in a certain way. Is there a best way? No. Is there a convenient way? Yes. And that's through your IDE. You're already in there writing code. It's easy enough to push and pull code there as well. And even that can be intimidating or confusing. And if that's the case, there are visual interfaces like SourceTree. If you're interested in learning more about Git, I have some resources available on my GitHub account that's in the description of this video. I would wholeheartedly recommend browsing those and learning from actual experts that aren't me. The long and short of it is this. A version control is more than just a fancy save button. You can go back to any point in time. Extensions in your IDE allow you to read commit messages in line, which means you don't need to write more comments in your code. And 6 months from now, you'll have a better idea of why you wrote whatever you wrote the way that you wrote it. And the more often you commit and the better your commit messages, the more useful version control is. And you don't have to work on a team to benefit from version control. I will also add, aside from all the great benefits of Git, something that is really cool is that when all of your code is centralized and web accessible, you can do really cool things like Git-based deployments. So you can code on your workstation, push it up to your Git repository, set up an automation server. It pulls code down from your repository and then runs it. No more copying files to the server. You know that the only code running on the server is code that's in the repository. This is especially great when paired with access controls or utilizing pipelines to enforce formatting and other standards, tests, that kind of thing. And the only gotcha here is, especially if you're hosting your code on a provider like GitHub, is don't leak sensitive information into your repository, which conveniently takes us to our next section. Security is a real issue. Where I'm from, tons of jurisdictions have had some pretty nasty ransomware attacks. While I've never heard of GIS being the entry point for any of them, I wouldn't want to be the first. The idea here is you are not having your usernames and passwords hard-coded into your automations. security-wise, in the Esri world, doing things that you want automated normally means you're utilizing a fairly well-privileged user. Those are exactly the kind of credentials that you want to keep safe. Alternatively, there are also API keys that we deal with for services like Bing or Nearmap that we also want to keep secure. We would especially not want to commit those to a GitHub repository publicly and have someone use and abuse those, right? Or even privately and then have your account, whatever, maliciously targeted. And that's been a thing in recent years. So there are a lot of options to choose from in terms of secrets management. I'm in the whatever works camp. I think the easiest entry point is the Python library keyring. It uses the Windows credential manager to store secrets. The syntax is up here on the slide. It is fairly simple. You set the password once and then call get password anytime you need to use it. Anything can be a secret, really. You can obfuscate your server URLs, usernames, whatever. Once you start managing multiple servers or service accounts, then it becomes a bit cumbersome, and you'll want to consider a secrets manager with an API. API-based secrets managers work in a similar function. You call the secret and it returns the value. There are paid services and open source options as well. Again, you should prefer to use these once you start having to access multiple servers or multiple users, since keyring is bound to each user's Windows credential manager per machine, which means if you have a password that you need to update and you have 5 servers that all use that password or whatever, I'm just spitballing here, you would then have to use the set password command 5 times, right? So that gets old really fast. So if you find yourself in that kind of situation, that's where you'd want to get a secrets manager that has an API. So everything up to this point has really been around your development environment and adopting tooling and best practices. Here we switch gears a bit and talk about how you're writing code. A fun story. In Texas, we have these things called appraisal districts, and they're quasi-governmental and kind of like the assessor treasurer's office here in Washington. It's fairly early in my career. I'm at a conference, and this guy who works at an appraisal district is presenting his code he wrote for doing some GIS things, and it's more than 1,000 lines long. And he sheepishly says, I wrote this before I learned about for loops, which is great. In the same kind of way that he wrote a massive script because he was unaware of control flow statements, afterwards he understood how inefficient that was and that there was a better way. I think this hindsight 2020 thing is really a hallmark of programming in general. You do things the wrong way for a while until you get frustrated or exposed to the right way a few times. Then afterwards, you adopt these new practices and you wonder how you ever did without them. These are the questions that I have asked and have been asked from a variety of people. You can Google this and get a fairly descriptive, numbered list of reasons or benefits to writing a function. I'll put it in another way. GIS people are storytellers. Our job is fundamentally to take complex ideas or complex data and present it in a visual medium that adequately communicates the data's story. In the same way that we strive to make our analyses meaningful to a variety of audiences, we should be taking the same care to writing our code and telling the story of that automation. Maybe that doesn't immediately click, so let's take a look at some code. Here we have some decorators for logging and a great doc string on our main function explaining exactly what's going on. You'll see that the function names are descriptive of their purpose: get local patches, get Esri patches, find product. So here the story is access our local file that has a record of the current patches, grab a copy of the patches file record online, look for the product that we're interested in, check to see if the online patches match with our local patches, and send an email. If the patch files are different, make some formatting changes, write to the log, send an email about what patches are available, write to the log that the patches file got overwritten. And if something crazy happens, send an email and ask them to check the logs. When we use well-described functions, we have a better, easily readable understanding of what the script does. But if you wanted to dig into how the script does it, then we need to look at the individual functions. And before we do that, it's worth teeing up the second part of this section. Type hinting was introduced into the Python standard library 10 years ago. And similar to the benefits that we discussed with functions, type hinting makes your code more explicit and easier to follow. Appropriate type hinting will allow your type checker to catch inadvertent bugs. The syntax is pretty simple and is added into the function's signature. When you highlight a function, the signature will appear and you'll get additional information. In the same way that you pull up the docs when looking at the ArcGIS API for Python or ArcPy, your own functions can and should be equally descriptive. Putting our two discussions together, we clearly explain what variables we're expecting, the types of those variables, and then the code that goes along with it. Here in our find product function, the actual code is only 5 lines. We're just trawling through the JSON looking for our item of interest. This is a piece of code that we would have needed to use twice since we're hunting against the local patch file and the online patch file. But even if we used it once, it would be worth putting it into a function because it abstracts away the process. We don't necessarily need to know how it's doing what it does. If we're reading through the main function, we just want to have an understanding of what it's doing. Here we're just making a bit of text formatting since the file itself isn't descriptive like that. Again, we don't necessarily need to know all the changes we're making within the map function, just that some formatting is needing to happen. And some self-criticism here, we're actually doing a little bit more than formatting things. We're also checking the diff between them. So maybe that could have been popped into a new function to separate those concerns. This function is a bit overwritten. It doesn't make any assumptions about if there exists a current patches file. So it checks to see if one exists, and if not, downloads it from the web. Outside of the first time that this automation runs, this function just loads up a file content in JSON format. And this one is only 3 lines, and we actually used it in the previous function to fetch a new patches file if one didn't exist. If this were in the main function, it would only be 2 lines of code, which is fine, but we also aren't trying to confuse the casual reader about making requests. Hopefully the presentation lived up to the hype. In lieu of building a time machine and giving myself the presentation that I wished I would have had, I'd love to hear from you. Yeah. And I promise that we talk a little bit about API. Maybe you can hear my dog barking, maybe not. So what I will say about API, about AI and bots in general, is that they are good for some things like writing docs. You should write docs, but I don't know that it's a great thing for a human to do, right? It's pretty boring and it's something that the bots excel at. But I would be less, I'm less thrilled to use it to write actual code, even boilerplate code. And what I think about that is that programming is a creative act. And although it's utilitarian in nature, like we're doing stuff with it, it is something that you as the writer need to understand what it's working, right? The Copilot or Gemini or whatever bot you're using is going to give you code. But if you're just a very casual developer and you don't understand what the code is doing and it breaks, it's going to be really hard to fix it or debug it. And then maybe you're like sicking another AI on your AI to debug the code for you. But you're going to have a very difficult and frustrating time if you don't understand the code that you're writing or you're responsible for maintaining code that you fundamentally just don't understand. If we get to a point where the bots are writing all the code and people aren't writing any of the code, I think we're gonna have bigger problems than uh, than we don't get to write code anymore. So that's my real bummer ending to the presentation. AI is something. Uh, but I wouldn't really believe the hype from the tech CEOs. Who knows? Um, anyway, so that's me, and hopefully this presentation gave you a bit better idea as a GIS developer, some things that you can do to get better at your geospatial Python development. I'm available at the following locations. Feel free to reach out to me. Again, big thank you to WAGISA for allowing me to present at the 2025 conference, and totally sorry that I tried to fit a 40-minute presentation into a 20-minute time slot. So that's that. Thank you so much. And, you know, some cool catchphrase.